Then energy performance assessment of compressors. Okay, energy performance. The subject is very tedious one. In thermodynamic point of view and electrical point of view, we can analyze the things. And very tedious subject. I can write the energy audit. I wrote the energy audit examination for 4 papers. One is general energy scenario concept, another one is thermal utilities and electrical utilities and performance assessment, which is calculation part. Okay, I passed only 3 papers, and fourth paper is a open book test. I failed the paper last year. Okay, very toughest exam. And that exam, we had four books and four tests in our syllabus. They are put in together in a single subject. Therefore, that syllabus is very vast. Therefore, I cannot explain detail for all components. Okay, in third unit, this also compressor, pump, fans also available in the third unit. Okay, therefore, but in third unit is very. I already said boiler, furnace, cogeneration, these things, cooling towers, these things are covered in the third unit. Therefore, remaining topics, which is compressor, fans, blowers, cannot tell any problematic concepts. Only it tells the theoretical concept alone. Therefore, for that concern, today it starts the compressor energy performance assessment of a compressor. Okay, and everybody knows what is compressor and types of compressor: reciprocating compressor, rotary compressor, and screw compressor. This type of things is already studied in previous hydraulics and pneumatic subjects and any other subjects. Okay, therefore no need to tell the structure of the compressor. So directly I go to the performance calculations, performance terms. Okay, what is the performance terms of the compressor? While we see the energy auditing. Okay, then the compressed air system is not only an energy intensive utility but also one of the least energy efficient over a period of time. Both the performance of compressor and compressed air system reduces drastically. The causes are many, such as poor maintenance, wear and tear, etc. All these lead to additional compressors installation, leading to more inefficiencies. A periodic performance assessment is essential to minimize the cost of the compressed air. Okay, the compressed air, the application of the compressed air is many places. In in industry, in assembling car assembling industry, in in every fitting places we can use the they are using the pneumatic operated screwdrivers, pneumatic operator spanners. Okay, these are all the operated with the help of compressed air system. Okay, therefore the main in a particular industry, 30% of power is utilized for the compressed air system. Okay, therefore we can conserve the more energy when we maintain the that compressed air system in proper manner. Okay, this is the main part of the any industry. Compressor is the main part of the consider. If you consider the train, the compressed air which is used to stop the train with the help of braking system. Okay, so if we fail the compressed air system, damage, we cannot drive the without compressed air system. We cannot drive the train and in buses, anything. In buses also having air braking system with the help of compressed air. Therefore, the usage of the compressed air is very vast in it. Okay, therefore the compressed air system, if you use proper manner, we can conserve or we can save energy. Then purpose of the performance test. So to find out the actual free air delivery of compressor. Free air delivery means if we unlock during the unlocking of the valve, inlet and exit, is completely open. Okay, the tank also completely open. At that time, if you on the compressor, then how much amount of air sucks and how much amount of air delivered. This is called free air delivered. Okay, once we lock the tank, then only pressure is raised. Okay, if you unlock during the unlocking time, that how much amount of air is supplied to the tank is called free air delivery. Okay, then isothermal power, which is minimum power requirement. Okay, minimum power requirement during compression process, the theoretical compression process temperature remains constant, there is no heat transfer. Okay, but in the actual case during compression the cylinders gets hot, which means the heat transfer is occurring. Okay, then isothermal power required, then volumetric efficiency. Okay, volumetric efficiency is theoretical volume, total volume divided by the relation ratio between total volume and actual volume flow rate. So because when speed increases the flow decreases. Okay, it will affect the discharge. Therefore, the specific power requirement. Okay, which means how much amount of current to generate certain amount of certain to raise the certain pressure. Okay, specific power requirement. The actual performance of plant is to be compared with design standard values for assessing the plant energy efficiency. Okay, then you can see the performance parameters one by one. And compression ratio is absolute discharge pressure of last stage divided by absolute intake pressure. Compression ratio. Already we discussed in thermal engineering and Otto cycle, this cycle, the compression ratio is equal to V2 by V1. Sorry, V1 by V2. Then the absolute discharge pressure of last stage after compression divided by before compression. Okay, then isothermal power. It is the least power required to compress the air assuming isothermal condition. Constant temperature condition. Then isothermal efficiency is the ratio of isothermal power to shaft power. Okay, isothermal power, the work formula for the isothermal process is equal to W equal to P1 V1 ln P2 by P1. Okay, it's the formula for the isothermal power. And shaft power is the actual electricity input is given to the compressor. Okay, it's a shaft power. And volumetric efficiency is the ratio of free air delivered to the compressor swept volume. Okay, the free air delivered is what is the free air delivered? I already explained. Then compressor swept volume is total volume into total volume minus clearance volume. Okay, swept volume is stroke volume. Okay, this is called clearance volume. The difference between total volume and clearance volume. Okay, then specific power requirement is the ratio of power consumption to the volume delivered at ambient conditions. Okay, then measurement of free air delivered one by one. Field testing procedure is one by one. I shared the document. If you are interested, you can study the things. I can directly go to the formula section. This is the layout of the compressor. First filter, then pressure and temperature gauges is available, then air compressor, then receiver, bypass valve, flow straighteners, and is sent to the testing chamber to test the free air delivered. Okay, the free air delivered, the formula is large size, K flow coefficient, pi d square, and T1 P1 is initial temperatures, and P3 P4 P3 RA, these are the pressure gauges. The gas is sent to the nozzle, then what is the pressure difference? With the help of this pressure difference, you can calculate the velocity. From the velocity, you can calculate the discharge. Q equal to AV. This concept only we can we can calculate the how much amount of free air delivered for a particular compression. Then isothermal efficiency. Isothermal efficiency is the ratio of isothermal power to input power. Then isothermal power is P1 QF1 ln R. P1 is pressure, Q is F is discharge, and ln R. R is the pressure ratio, P2 by P1. Remember the first law of thermodynamic concept. Isothermal work is P1 V1 ln P2 by P1 is equal to V2 also V1 by V2. You can write. Then here P1 and volume is here. I notated volume as a Q discharge, and ln R. Log E is called ln, therefore ln R. R is the pressure ratio, P2 by P divided by 36.7. Okay, 36.7 means here they are put certain value for input power, 36.7. Okay, input power, it is the standard nameplate value, 36 point, how much amount of kilowatt of a particular compressor. Here they are only writing example, okay, not a constant. It is not a constant, it is only example. 36.7 is the only number. Okay, it is the one rated value of a particular compressor. Okay, then P1 Q1 R. Then specific power consumption. Power consumption divided by free air delivered. Specific power consumption at rated discharge pressure. Okay, at atmospheric conditions. Okay, called the power consumption divided by free air delivered. Okay, the power consumption is already measured, and free air delivered also already calculated. With substitute things, you can get specific power consumption. Okay, then volumetric efficiency is free air divided by swept volume. So compressor swept volume is also called compressor displacement, piston displacement from top dead center to bottom dead center. Okay, the swept volume is called swept volume, is also compressor displacement or stroke volume. Okay, this is the pi by 5 d square. D square is the bore diameter of the cylinder, and L stroke length. Okay, yes, compressor speed and psi symbol, one for single acting and double acting, and a number of cylinders. Similarly for IC engines. Okay, performance you can calculate the performance calculations. Remember that in lab time also. Then compressor displacement, stroke volume is also called stroke volume, is equal to pi by 4 d square L into n. Notation is a different here. Okay, S is a speed, and X is for single acting, double acting, and S number of cylinders. Okay, in generally we can see the reciprocating compressor is a V type, 2 cylinders. Okay, with the help of this formula we can calculate the compressor displacement, and then from that we can calculate the volumetric efficiency. Okay, these are the theoretical concepts of to find out the compressor efficiency. With the help of this calculation we can consider or conclude the how much amount of energy utilized for the particular compressor section, and from with the help of these values we have some inference, and we suggest the things to the management, and management takes necessary action to conserve the energy. Okay, these things are occur. Okay, this is the energy performance assessment of the compressor. Okay, I skip the problems, tutorial problems for compressor, and tomorrow we discuss about the fans and blowers. Okay, thank you.